Hello friends, this video on chemical bonding part 11 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 10. So till now we have discussed the covalent bond formation, right, where we have the share of electron. Now we'll discuss ionic bond formation where we have transfer of electrons. So the formation of ionic bond or ionic compound depends mainly on the ease of formation of positive or negative ions. Right? Because I have suppose sodium and chlorine. If sodium can easily give electron here, sodium can easily form positive ion, chlorine can easily form chlorine ion. That means NaCl is a possible compound. Right? So it all depends on the ease of formation of positive and negative ions from the respective neutral ion. For example, if you see for Mg, for magnesium, it can lose electron to become Mg plus, and then the energy required or energy unit is called ionization enthalpy. Similarly, for let's suppose any element X, if it can gain electron easily to become a negative ion, the energy gain is called electron gain enthalpy. So these energies are something which matters for creation of ionic bond. And if you see in this case, the electron gain process may be exothermic or endothermic. So this guy may give energy or may take energy, right? But this guy, the ionization enthalpy, always need energy, correct? So so to pluck out the electron, you always need energy. But to give one electron, sometimes the atom gives energy because it attains the stability, or sometimes you have to provide extra energy to make sure that the atoms takes extra electron. Correct? So ionic bond is formed easily between the elements which has low ionization enthalpies and high value of electron gain enthalpy. That means this guy, it emits a lot of energy when it gains the electron, but it needs very small energy to pluck out electron, right? So very simple. So it is like this: small energy to pluck out electron from metal generally, and large energy emitted when electron is added to non-metal. So if this is the case, it's easy to form bond. For example, NaCl, very small energy is required to pluck out electron from sodium to become Na plus, and it gives energy when it forms Cl minus. Correct? Also, only these two energies are not responsible for creating ionic bond. The third energy is also required, it is crystalline energy, because the arrangement of this positive and negative ions in the solid also gives some energy, the lattice, right? So it's all, as I told, energy is all stress, right? So if people are arranged in a proper way, the stress is less and there will be less energy. See, if you arrange things in a proper way, the energy is less. For example, if you arrange things like this, one square, one circle, one square, one circle, like this, some pattern is there. So with this pattern, the energy is less because things has less stress. But if you haphazardly put some items here, 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 so looking at this only you can feel out the stress, right? With this, the less stress. So it has less energy and it is stable. That means when you form this kind of lattice where you have particular structure, right, positive, some structure, some pattern you follow, it gives out energy because it has finally become stable in the life, right? So it gives out energy. So if it gives out energy, so there's a plus sign here. If this gives energy, if this gives some energy, so these two can compensate for this negative energy. And if overall you have positive value, that means it will form ion on its own. Ionic bond. Hope you understand this. See, for manganese to become manganese plus, you need some energy, right? But for some other, let's suppose non-metal to gain electron, you may get some energy. Let's suppose you got some energy. And also when they got this, let's suppose NaCl, it got this, when it crystallizes and forms pattern, it further loses energy. So it gives some energy. Since this NaCl is losing the stress by arranging itself in a particular fashion, it loses some energy, and thus this gives some energy. So if some of these energy, all this energy, positive, negative, with some positive value, the ionic bond is formed. Let's take this lattice energy in a more detailed way. So lattice energy is nothing but energy released. Please note it's always released when the number of positive and negative ions combine to form 1 mole of ionic compound. And why they release energy? Because as I told that, if you see, the ionic compounds are generally crystalline, right? And they are 3-dimensional arrangement of cations and anions, and they're held by Coulombic interaction. So if you see the way, so if they are, let's suppose Na and Cl, Na has plus and Cl has minus, so there are 2 charges. This is for Na and this is for Cl. And then the formula is force, the Coulombic force is K into Q1 Q2 by R square. Whereas R is the distance between the ions, right? Negative and NaCl ion, you see I have sodium and I have chlorine molecule, the distance between them is R. So this is the force that is there which binds this. This is the sodium NaCl only. This is NaCl, and this is arranged in this fashion. This is having less stress, it has less energy. So how it has less energy? Because the moment it formed this, it gave some energy, it released some energy, and that energy is called lattice energy. Because it had some haphazard sodium chlorine like this, right? And now it has crystalline in this fashion. Any fashion. So since it is in a particular fashion now, it has released energy. It is less stress now for us because it's in a particular pattern. So with the pattern, the energy is less. Since the energy is less, that means it has released some energy, right? It has released some energy, and that energy is called lattice energy. Hope you understand this. Lattice energy is nothing but when it is happens that it has more energy. This guy has more energy. When it is crystalline in some structure, it has less energy, right? So where did the energy go? The energy came out in the form of lattice energy. And this energy is also used to compensate for the electron gain enthalpy and the ionization enthalpy. Correct? So that's why to sum we can say that, or to add the final statement we can say that the sum of electron gain enthalpy, ionization enthalpy may be positive, but the crystal structure gets stabilized due to energy released from this guy, lattice energy. The overall thing is metallized. See, let's assume that for electron gain enthalpy you need 10 joule energy. For ionization also you need 5 joule energy, let's suppose. But for lattice, the energy release is 20 joules. So overall you are still getting 5 joule energy, right? Because this is lattice energy. This is my E gain, and this is my ionization enthalpy. Right? So overall it has to be, because sometimes the lattice energy is so high that it compensates for this energy because this is emitted. Correct? Sometimes electron gain enthalpy is also emitted. Sometimes it is exothermic. Lattice energy is always, this reaction is always exothermic because when it is crystallized, it is having less energy, less stress. So that means it has given out the stress, it has given out the energy. Let's take the formation of NaCl. So ionization enthalpy in this case is that means to become Na plus, it needs 495 kilojoule per mole. Electron gain enthalpy is this much, that means it emitted this much energy. So that means, see, the convention I used was just opposite last time. Just understand this. It need this much energy. It gave this much energy, and this guy also gave this much energy, right? So in this case, we have taken in this fashion. So it need this much energy. So this energy is compensated by these two energy, because chlorine to become Cl minus ion, chlorine gave this much energy, 348.7 kilojoule per mole, and NaCl, when it got crystallized, it gave this lattice energy because it is little more peaceful, more stable in life, so it gave this much energy. But for Na to become Na plus, this wanted this much energy. But overall, if you see this energy, if you add all these, that means overall it gave some energy. That's why if you have the sodium and chlorine, you don't need to heat it. It will just form NaCl, because overall this and this energy which is released will compensate for the energy needed. Right? So now if you see, if you want to find the stability of the ionic compound, I'm talking about ionic compound, please note. So that is provided by enthalpy of lattice formation. The lattice energy plays a critical role in ionic compound. So just by looking at the octet of electrons, we can't tell the stability of the ionic compound. And that's what I told the demerits of the Lewis theory was, it could not explain the stability of the compounds easily, because for stability of the compound there are some other energies also involved. For example, in the case of ionic bond or ionic compound, the lattice energy plays a critical role. Till now we have learned lattice energy. Lattice enthalpy is just opposite of that. So lattice enthalpy is nothing but energy required to complete separate 1 mole of solid ionic compound into gaseous ions. For example, I told I have Na and Cl in the gas form. It will form the lattice structure. It will release some energy. Now if I have the solid form where it is stable, and now I want to pluck out the sodium and chlorine from this and make it into gaseous state, I need to provide energy. Obviously, because when sodium and chlorine were in gaseous forms, Na plus and Cl minus ion in gaseous forms, the moment it combines, it release energy to form NaCl solid. Now if you want to put it back to NaCl, Na plus and Cl minus gas ions, you have to provide energy, and that is nothing but lattice enthalpy, right? So when I say lattice enthalpy of sodium is NaCl is 788 kilojoule per mole, that means this many 788 kilojoule of energy is required to separate 1 mole of sodium chloride into 1 mole of Na plus and 1 mole of Cl minus gas to infinite distance, right? So that means I have this is my NaCl in some crystal form, right? Now from this I want to separate my, let's suppose, Na plus and Cl minus to infinite distance, then I need to provide this much energy. So we discussed a lot about ionic compound. Let's discuss some properties of ionic compound. The first is they exist in solid state because, as I told you, there is a strong attraction between this. The Coulombic attraction is very, very strong, and they also have this lattice arrangement, 3-dimensional arrangement. So generally they exist in solid state. They are crystalline structure. They are arranged in a regular pattern, just discussed. Since the attraction between the ions are very strong, so they have generally high melting and boiling point, and they are soluble in polar solvent because they have this charge thing, plus and minus. So if you have something polar solvent like H2O, which has a charge like this, -2 partial charge, so in such polar solvent they are soluble. They are good conductor of electricity because they have charge and they have electrons to conduct electricity, and the ionic reaction is very fast.